In this video, I'm going to show how to check my graphing work on a graphing calculator. So in this sample problem, I've got a system of equations, and my problem was to solve this system by graphing. So I already did that. The first equation was already in y equals mx plus b form. So I used the intercept and the slope to graph that equation. And then the second equation, I brainstormed some points and plotted those. I guess I did the y-intercept and the x-intercept. And so when I look for the solution of a system, I'm looking for the intersection point. And so I've come up with the ordered pair -2, 4 as a solution, but it's a good policy to always be in the habit of checking our answer. There's several ways to check. One of them is to plug in the x and y values to both equations. A different way to check is to use a graphing calculator. So to get started, I press on for the power, and I'm going to press this y equals button. And you can see my equation, my first equation up here, y equals. And the different equations are numbered like y1, y2 we'll use right now. And so y1, I'm going to type in -3 minus 2. Oops, I forgot my x. I can back up, second insert, and my x is right here. There's a lot of variable names on that key that you would use in different statistics classes, trigonometry classes. For us, we use x as our variable a lot of times, so x, there it is. And then I just press this graph button, and if everything's in order, I get the graph of my first line. Now the second one is a little bit more work, because when we press this y equals button again, we noticed all the equations are organized as y equals, so they're all solved for y. So I need to do a little bit of work on paper first before I come back. I'm going to take my second equation, 2x minus y equals -8, and solve for y so that I can enter that into my calculator. So one way to do this is subtract 2x from both sides, and then divide by -1 each term. So y equals 2x plus 8 is the equivalent equation that my calculator can work with. I'm using the arrow keys to arrow down to my next equation spot. 2, and this time I'll remember the x. 2x plus 8. And again, I press graph to see, here's my second line. So that looks like a pretty good match to what I graphed by hand. But I want to know that intersection point exactly. There's a trace button on your calculator. And you can see down here it's telling you an ordered pair, and that's the blinking cursor. Over 0, down 2 is the location of that point. The trace function, you move along the line with your left and right arrow keys, so it's climbing up there. Honestly, doesn't do a lot for us. We get all these decimal numbers, not typically what we're interested in. So the much more useful menu, you press this second, it might be a different color on yours, but it's kind of like the shift key on your computer to get up to the menu item above that trace key. And it'll match in color. So mine is blue, and then calc is the blue menu item. So what we know we want when we solve a system of equations is the intersection of those two lines. So I can arrow down, or I can type in number 5, either way, enter. The calculator is going to ask me a series of 3 questions, and it's important to answer all 3 before I read my answer. It's a really common mistake for people to say, I pressed intersect, and so now the answer is x equals 0.85, y equals minus 4.5. Well, the cursor's not on that intersection yet. The calculator is asking me a series of 3 questions, saying first curve. Is that the first curve we want to use? Yeah. Look, it jumped up to this other one, Is that the second curve we want to use? Yeah. So I'm hitting enter to say yes. And the third question finally is guess. Honestly, you can ignore that. It's just saving the calculator a few milliseconds of work if I use my arrow keys to go over a little closer to the intersection and press enter when I'm ready. And now it finally says intersection x equals -2, y equals 4. So that does check with the work that I did on paper.